Right now, as you watch this video, something invisible is happening. Your device sent a tiny message across the internet, and somewhere in the world, a machine received it, found exactly what you needed, and sent it back in less than a second. That is not magic. That is not luck. That is a system called client-server architecture, and once you understand it, you will never look at the internet the same way again. Every time you check your messages, search for something online, stream a show, or log into your bank, this system is doing the work. It is the backbone of the modern internet, and almost nobody who uses it every day actually knows how it works. Here is what we are going to cover in this video. We will start with the big question: what problem does client-server architecture actually solve? Then we will break down exactly what a client is, what a server is, and how the two talk to each other. We will look at real examples you already use every day. And we will walk through the different versions of this architecture, from the simplest form to the kind that powers global applications with millions of users. You do not need any coding knowledge. You do not need any technical background. All you need is the curiosity to understand how the world around you actually works. Let us start at the beginning. Before client-server architecture existed, computers did not talk to each other the way they do today. If you wanted information stored on another machine, you had to physically bring that machine to where you were or copy everything onto a disk and carry it yourself. That worked fine when computers were rare and expensive and only large organizations had them. But then something changed. More and more computers appeared. Companies started having dozens of machines in the same building. Universities had hundreds. And a simple but enormous problem emerged: how do you let many different machines share the same data without making a mess? If every machine had its own copy of the company's customer records and someone updated one copy, none of the other machines would know. You would quickly end up with 12 different versions of the same information, all contradicting each other. Someone had to be in charge. Someone had to hold the one true, official version of the data, and everyone else would have to ask that someone whenever they needed anything. That idea, one central machine managing the data and many other machines requesting it, is the core of client-server architecture. The machine in charge is called the server. The machines making requests are called clients, and that relationship client asks, server answers, is the foundation of almost everything you do online today. Let us make these two words very concrete. A client is anything that asks for something. In most cases, the client is your device, your phone, your laptop, your tablet. More specifically, it is the application running on your device. Your web browser is a client. Your email app is a client. The banking app on your phone is a client. Anything that sends a request to get something, that is a client. A server is anything that answers those requests. A server is usually a very powerful computer, kept in a large building called a data center, running around the clock. Its entire job is to wait for requests to arrive and respond to them. One server can respond to thousands, sometimes millions of requests every single day. Now here is something important. The word server can be confusing because it sounds like it must be some enormous, expensive machine. And sometimes it is. But at its most basic level, a server is just a computer running a program that listens for requests and knows how to respond. Think of it this way. Imagine you walk into a restaurant. You are the client. You sit down and look at the menu. When you are ready, you ask the waiter for your food. The waiter carries your request to the kitchen. The kitchen prepares it and sends it back. You receive exactly what you asked for. The waiter in this picture is the network, the internet, carrying messages back and forth. The kitchen is the server. And you, sitting at the table with a need and a request, are the client. That exchange you ask, the kitchen delivers, is the entire client-server model in a nutshell. So how exactly do a client and a server talk to each other? Let us walk through what happens when you type a website address into your browser and press enter. Step 1. Your browser, the client, takes that address and turns it into a request. That request contains information like, what page do I want, what kind of content can I handle, and who am I? Step 2. Your request travels across the internet to the correct server. It does not wander aimlessly. There is a system called the domain name system, which is essentially a massive phone book for the internet that translates the website address you typed into the exact numerical location of the server. Step 3. The server receives your request. It reads what you are asking for, goes and finds the right information, and prepares a response. Step 4. The server sends that response back across the internet to your browser. The response contains the content you asked for the web page, the image, the video, whatever it was. Step 5. Your browser receives the response and displays it on your screen. The entire process from the moment you press enter to the moment the page appears often takes less than half a second. And all of that is happening invisibly every single time you use the internet. There are rules that govern how clients and servers communicate. These rules are called protocols. The most common one, which you have probably seen at the start of website addresses, is called Hypertext Transfer Protocol, or the secure version, Hypertext Transfer Protocol Secure. These protocols make sure both sides speak the same language and understand each other perfectly. You can think of protocols as the shared etiquette of the internet. They decide how a request should be written, how a response should be packaged, and how errors should be handled if something goes wrong. Without that common structure, clients and servers would not know how to work together reliably. Let us look at some examples you already know and see the client-server architecture at work inside them. When you search on Google, your browser is the client. It sends your search words to Google servers. Those servers search through an index of billions of web pages, find the most relevant results, and send them back. All of that billions of pages checked in under a second. That response is not just a list of links. It is ranked, filtered, and assembled for speed. The server is doing a huge amount of work behind the scenes so that the page you see feels instant and useful. When you send a WhatsApp message, your phone is the client. It sends your message to WhatsApp servers. Those servers store the message, and when your friend's phone comes online, deliver it. WhatsApp servers handle billions of messages every single day this way. When you stream a show on Netflix, your television or laptop is the client. It sends a request saying, "I want to watch this specific show, starting from this specific point in time." Netflix's servers find the right video file, break it into small pieces, and stream those pieces to your device continuously as you watch. When you check your bank balance, your banking app is the client. It sends a secure request to the bank servers. The servers check your account information and send back your current balance. The actual money and all records of every transaction live on the server, not on your phone. In every single one of these cases, the pattern is the same. Your device asks. A powerful computer somewhere else answers. The client-server architecture is the engine powering all of it. Not all client-server systems are built the same way. As the needs of applications have grown, different forms of the architecture have emerged. The simplest version is called one-tier architecture. Here, everything lives in the same place: the user interface, the logic, and the data are all bundled together on one machine. It is like a personal recipe book. Everything is in one place and works fine for you, but you cannot share it easily with anyone else. This works for small, standalone applications, but it is not suitable for anything that needs to be shared across a network. The next version is called two-tier architecture. Here, the client and the server are separate. The client handles what you see and interact with. The server handles the data. They talk directly to each other. Think of it like an old-fashioned cash register connected to a central inventory database. The register is the client. The database is the server. They communicate directly. This works well for smaller systems with a limited number of users. The most common version today is called three-tier architecture. Here, a third layer is added between the client and the data. That middle layer is called the application layer or the logic layer. It is the brain that processes your request before going to the data, and it is the brain that prepares the response before sending it back. The client no longer talks directly to the data, it talks to the logic layer, which talks to the data. This separation makes systems much more secure, much more scalable, and much easier to maintain. That extra layer matters because it keeps responsibilities separate. The client can stay lightweight, the logic layer can change without breaking the interface, and the database can stay focused on storage. When each part has a clear role, the whole system is easier to understand and much easier to evolve. Most of the applications you use social media, e-commerce, banking use three-tier architecture or an even more sophisticated version that adds further specialized layers for things like security checks, caching, and load distribution. So why has client-server architecture become the standard way of building systems? What makes it so effective? The first reason is centralized control. Because the data lives on the server, there is always one official version. Every client that connects gets the same, current, accurate information. No contradictions, no outdated copies, one source of truth. The second reason is scalability. A single server can serve thousands of clients at the same time. And when the number of users grows, you can add more servers to handle the extra load. The architecture can grow with the demand. The third reason is security. Because sensitive data stays on the server and does not live on every individual device, it is far easier to protect. Access can be controlled, monitored, and restricted from one central point. The fourth reason is maintenance. When a developer needs to update the system, fix a problem, add a new feature, improve performance, they update the server. Every client immediately benefits from that update without needing to do anything themselves. This is why apps that live on servers can improve continuously, while the version on your phone barely needs to change. That is a huge reason web apps became so practical. One update on the server can improve the experience for every user at once, instead of waiting for millions of people to install a new version manually. Here is what we have covered today. Client-server architecture exists because the world needed a way for many different machines to share the same data reliably. It works through a simple request-response cycle. The client asks, the server answers. It comes in different forms, from the simple two-tier model to the sophisticated three-tier systems that power the apps you use every day. And it is effective because it centralizes control, enables scale, protects data, and makes maintenance simple. The next time you open a browser, send a message, or check your bank, you will know exactly what is happening under the surface. A client is sending a request. A server is receiving it, processing it, and sending something back. In less than a second, the result appears on your screen. That invisible conversation has been happening billions of times a day, across the entire internet for decades. And once you notice it, you start seeing it everywhere, in every login screen, every search box, every stream, every app refresh, and every secure action you take online. And now you know exactly how it works. If this changed how you see the internet, leave a comment telling us which example surprised you the most. Was it Google, WhatsApp, or Netflix? Drop it below. We read every single one.